In this section, we'll take a look at the configuring and monitoring BGP objective of the JNCIS Service Provider exam. We'll examine how to configure iBGP and eBGP and how to use policy to control routing announcements. For more detailed coverage of this objective and more, please check out the JUNOS Intermediate Routing course. In this video, we're going to take a look at the basics of BGP configuration, both eBGP and iBGP. And this is the network that we're going to be working with. As with previous examples, most of the routers in this network are already configured. All we're going to be doing is we're going to be configuring R1. And the setup we have here is we have a iBGP mesh within AS 65000, and he is acting as a transit network for these ASs on the outside, 65530, 65531, and 65532. And what we're going to do is we're going to configure R1 with his iBGP sessions facing into the AS and one eBGP session facing this remote AS. And we'll see how routes between these three external ASs flow through AS 65000 and reach each other. So let's now jump into the configuration. So we're now on R1. Our router ID and autonomous system has been configured ahead of time. As has our loopback interface. But we're going to need to add our BGP configuration. We don't have any BGP configuration there. So what we need to do is configure one group for iBGP sessions and another group for an eBGP session. So let's configure this now. We need to specify the type of session when you're configuring BGP. So for our iBGP group, we're specifying type internal. This means that we're expecting neighbors to be established with the same autonomous system number. We're specifying a local address. This is because we're changing BGP's default behavior of using the egress interface to using a specified interface. In this case, we're using the loopback interface because this maximizes resiliency for iBGP sessions. And we're also configuring an export BGP policy that's going to be applying next hop south. If you remember from the theory videos, this is so the next hop of the routes that we're advertising to iBGP speakers can be resolved by remote iBGP speakers, because we're not going to be advertising the interface that interconnects to our eBGP speaker into our IGP. Let's just have a look at this policy now to confirm what it's doing. And there you can see. So for eBGP received routes, we are setting next hop self on export to iBGP speakers. So we've got all our group shared configuration configured now. So what we need to do is we need to configure our BGP neighbors. And we're all in the same range, so it's nice and easy to configure. There we go. This is our iBGP configuration. Let's commit that now and see what effect that has. Show BGP summary is always a good command to start troubleshooting BGP with. So you see that we have our 5 BGP sessions not yet established. Need to wait a little time for them to establish. You see that they're starting to come up now. And there we have it. We have all of our iBGP sessions up. You see these numbers here. These numbers mean that we are receiving routes from these IBGP speakers. So we've got one active route over each session. So let's now have a look at the routing table and see if we can see these routes in our local routing table. Yes, we can. We can see these routes that have been received via these external ASNs that have been advertised to us over our IBGP mesh. So we have our IBGP configured. As we can see, now we need to configure that eBGP session. So we're configuring a different group this time. And because it's an eBGP session, we're saying type external. And we're going to be configuring this session on this interface. And we're going to give the neighbor the remote IP address on this link. Default behavior of BGP in this case of sourcing the session from this address is acceptable for us, so we don't specify a local address. And of course, this is eBGP now, so we need to specify the remote ASN. So we have our eBGP group added to give us this full BGP configuration. So let's commit this configuration now. And again, good place to go to for BGP state information is show BGP summary. So you can see we've got our external BGP session configured with a different ASN here. And we're just waiting for this to establish. And there we have it. The session is up and running. You can see that we are receiving some routes over this session. Let's have a look at what effect this has had on the routing table. There we can see that the route has been received from this external speaker. So one final thing to check here is what the status of the routing tables are on the external BGP speakers. So if we hop on to the router that we've just configured our neighbor to, you can see he's got this session being up for 1 minute. And you can see that he has learnt the loopback addresses from the other XR routers via the transit AS of 65000. And another final check. So if we hop on to R6, so that's this router here, let's see if our next hop self policy has taken effect. So we've learnt the route from this speaker via R1. And at this point, the next hop is going to be this IP address here. R1 is then going to advertise the route to R6 over IBGP, and he's going to set next hop self. So the next hop of the route, by the time it gets to R6, should be the loopback of R1. So we can see the route in R6's routing table. Let's have a look with the detail flag. And we're looking for the protocol next hop. And it has indeed got the next hop set to R1. This was a quick introduction to BGP configuration. In this video, we're going to take a look at BGP routing policy. So we're going to continue using the network that we configured in the previous BGP demonstration example. And if you remember from that example, how we left that network was that we had the loopback addresses from XR1 and XR2 and XR3 being advertised to each other via our intermediary AS of 65000, because we had a full mesh of IBGP sessions running between R1 through R6. Now, what this network was lacking was the advertisement of R1 through R6 loopback addresses out to these ASNs. And this is what we're going to apply in this situation. We're going to apply the advertisement of this AS's loopback addresses from R1 to XR1. So let's get configuring. So this is the status of R1 as we left it. And when we're playing around with routing policy and how routes are flowing between different BGP speakers, this is a good command to use. So we're taking a look at the routes that we are advertising this eBGP peer. And we're doing that by saying show route advertising protocol BGP and the IP address. And this shows us the routes that we are advertising to this BGP speaker. And you can see that we are advertising the loopback addresses that we've learnt from the other XR routers, initially via eBGP and then via our IBGP mesh, extending from those remote destinations. So we've learnt from XR2 to R2 and from XR3 to R6, and then these routes have been propagated via IBGP to R1. We can do the opposite of this command. We can see what we are receiving from this eBGP speaker by using the receive protocol flag. So show route receive protocol BGP and the IP address of the neighbor. And we can see that we're receiving two routes from that neighbor. The one that we're interested in is the loopback. So this is the current status of this BGP neighbor. We're receiving its loopback and we're advertising the loopbacks of the other XR routers. But we want to be advertising the loopbacks of the routers within our AS. We want to be advertising all of these loopbacks. So to do that, we need to apply some BGP policy to our BGP configuration. So let's refresh our memory of the BGP configuration we have. We've got our IBGP group, and we've got our eBGP group. Well, obviously, we're going to need to apply this policy to our eBGP group. So first off, let's just see what happens when we filter routes from our eBGP neighbor. So we're applying a BGP policy at the group level of the configuration here. And we're applying a policy that I configured ahead of time, which is just dropping all prefixes. So if we apply that, we now take a look at the routes that we're advertising to our eBGP neighbor. Of course, we're not advertising any routes there at all, because we have this export policy applied at the group level that's filtering those routes. So what we actually want to do is you want to apply a policy that's going to identify the loopback addresses within our ASN, and we want to advertise those to this eBGP speaker. So let's do that now. This is again a policy I've configured ahead of time. Let's have a look at what this policy is doing. So we're identifying routes by protocol. So direct, local. So those are routes that reside on this router itself, and either IGP, ISAS or OSPF. And we're also limiting the routes that we're advertising to only come from the range of our loopbacks. So let's have a look at the configuration now. So we have a policy at the group level, but we have a policy at the neighbor level as well. And the reason I applied this policy here ahead of time is to demonstrate the fact that in Juniper configuration with BGP, we have this concept of the more specific configuration winning. This policy applied at the group level is less specific than this policy applied at the neighbor level. So it's the neighbor level policy that gets applied. We're not applying both of these policies. As soon as you configure something at a more specific level of the hierarchy, it overrides rather than adds to any configuration that happens to be applied for the same specific piece of configuration at a higher level of the hierarchy. So let's apply this configuration now. And let's recheck what routes we're advertising. And there we go. We're advertising all of our loopbacks that are within our AS that were identified by this policy. And you notice protocol BGP is not listed here. So how are we advertising the routes that we learnt from our remote XR speaking routers? Well, this is another way to further illustrate that we're only specifying this policy here. It's not applied in addition to this reject policy. If we have a look at the neighbor itself, it tells us the export policy. We clearly only have that one export policy applied. And if we look in more detail what this export policy is doing, we have this one term that's identifying these routes that we want to advertise. After this term is finished, and after this policy statement is finished, and that there are no other policy statements in the policy chain applied to this BGP neighbor, what happens is that we revert to the default protocol rules of BGP. And the default protocol rules of BGP mean that we are allowed to advertise iBGP learnt routes to eBGP speakers, which is exactly what we're doing in the case of these routes here. So we're following default BGP protocol rules to advertise these routes to our eBGP speaker. And this way we get all of these routes advertised to the XR1 router. Let's just finally confirm on the XR router that we are receiving all of these routes. Yes, we are. So we now have all of those loopback addresses from every router on our network learnt on this router. And hopefully this video demonstrated to you some of the basics of manipulating route flow in BGP with routing policy.